This is topic 3, solving polynomials using our greatest common factors. So the first thing I want to talk about is what is at the top of the page, the zero product property. What this is saying is if we multiply a times b, and if it's equal to 0, that means a is equal to 0, b is equal to 0, or they both are equal to 0. Because if you think about it, multiplying anything times 0 gives you 0. So we can use this property in order to solve. So the biggest thing is that we set each factor equal to 0. So we have two things being multiplied here. So this is my a, and this is my b. So I'm going to set a equal to 0 and b equal to 0. And then solve. The first one's already solved for us. The second one, we just need to add 8 to both sides. And we get x is equal to 8. So when we write our solution, we have x is equal to 0 and 8. And it doesn't matter if you write it two separate equal signs. I like to use the comma just because I'm lazier, but it's totally up to you. So if we look at the second example, the first set of parentheses is our a, the second set is our b. So set each of them equal to 0. 4m plus 8 equals 0, and m minus 3 equals 0. So the first one, solving, I need to start with the non-variable term. So I'm going to subtract 8 from both sides. 4m equals negative 8. And in order to solve, I need to get m by itself, so I must divide by 4. M is equal to negative 2. On the right side, all I have to do is add 3 to both sides to get m by itself, and I get m is equal to positive 3. So I will just circle both these answers. You can write it in whatever format you want. Go ahead and do the U-try. So in the last examples, we had it already factored for us. The hard work was done. So if the polynomial is not in factored form, we have to factor it first. So this is where GCF comes in handy. GCF of 5 and 15 is 5, and I have a p and a p squared, so I can pull out just one p. 5p times what is 5p? 1. 5 times what is negative 15? Negative 3. And I need a p squared, so I need to multiply that p by another p. It's still equal to 0. So now this looks like the last slide, where we have two things. Set each of them equal to 0. 5p equals 0, and 1 minus 3p is equal to 0. From there, on the right side, divide both sides by 5, and we get p is equal to 0. On the other side, start with the non-variable term, subtract 1 from both sides. Negative 3p equals negative 1. Then divide both sides by negative 3. So we get p is also equal to positive 1/3. Note that a negative divided by a negative gives us a positive. And don't write it as a decimal, keep it as a fraction. Go ahead and do the U-try. Alright, if the polynomial is not set equal to 0, we need to get everything on one side first and then factor, because the zero product property only works with 0 on the right side. So what we need to do is move that 3a to the left by adding it. So we have 12a squared plus 3a is equal to 0. So now that we have 0 on one side, we can factor. Note that I cannot add those two together. They are not like terms. We cannot add them. So GCF of 12 and 3 is 3. The GCF of a squared and a is just a. 3 times what is 12? 4. A times what is a squared? A. 3 times what is 3? Just 1. And a, we don't need to multiply it by anything else. So now is when we can set each of them equal to 0 and solve. On the right side, all I have to do is divide by 3. I get a is equal to 0. And on the right side, at first I need to start with the non-variable term. So I get 4a is equal to negative 1. And then divide both sides by 4. So I get a is equal to negative 1/4. So once again, I have two solutions. A is equal to 0, a is equal to negative 1/4. Go ahead and do the U-try, remembering that you have to get 0 on one side first and then factor. Let's take a look at word problems. I know they seem very scary, but in reality, it's the same as just what we just did. So the first thing that I want to look at is we're talking about a rocket that is launched straight up into the air with a velocity. They give you the formula that models the height. H of t is equal to 125t minus 16t squared, where h is the height, and then t is the time in seconds. So the first thing we need to do is think about what is the height when it returns to the ground. If we were to look at this, say this is the ground, we're sending off a rocket, it's coming back down. What is the height at ground level? The height is 0. Ground level, height is 0. And I believe we're talking about feet, so I may as well use my unit of measure. So, if h is equal to 0, we are plugging in 0 for h. So we have the formula 0 equals 125t minus 16t squared. So now because we have 0 on one side, we can go ahead and factor the right side. 125 and 16, those are both divisible by 4. Oh, no they're not, I lied. So they don't have anything in common. So we cannot pull out a number, but they do both have a t, at least one, so I can factor out a t. When I do that, t times what is 125t, 125, and t times what is negative 16t squared. I need to multiply it by negative 16, and t times t gives me t squared. So now I set each of those equal to 0. T is equal to 0, and 125 minus 16t is equal to 0. So the first one, this says time is equal to 0. Think about what that means. That's when we launch it. The question is asking us when it returns to the ground. So we want the other solution. We want the time at the ground level when it lands. So I'm going to put an x over this solution because that doesn't answer the question. Let's solve for t over here. The first thing that I need to do is move the non-variable term, so I'm going to subtract 125 from both sides. I'm left with negative 16t equals negative 125. And then I need to divide 125 by negative 125 by negative 16. When I do that, I get t is equal to about 7.8. So, because it's a word problem, we need to answer in words. So, we're say t is equal to 7.8. T is the time in seconds. So, our answer is 7.8 seconds. Go ahead and do the U-try. It mimics this directly, so set it up just like this problem and you will be successful.